Today is, okay, the other video is working. Good morning, class. Today is Wednesday, April 29th. Let's get started with some science. So this whole week we've been talking about the things that make up the ocean, and specifically the landforms versus the different levels of the ocean. So let's review our ocean continent song on the count of 1, 2, 3. I'm heading out to the ocean sea, 70% with high salinity. I'm heading out to the ocean sea. Stop. The shelf. The continental shelf of the ocean sea. Not too deep, just perfect for me. The continental shelf of the ocean sea. Stop. The slope. The continental slope of the ocean sea. Water gets deep oh so quickly. The continental slope of the ocean sea. Stop. The rise. The continental rise of the ocean sea. Bump at the bottom from depositing. The continental rise of the ocean sea. Stop. The abyss. And then yesterday we talked about the different layers of the ocean. So our new song is to the tune of Jump On It. And so the first layer is the epipelagic or sunlight zone, and it's up top. So we're going to point up this way. Epipelagic zone. And then it's the sunlight zone. So what we're going to do is swim, because that's what we would do in the sunlight zone. Zone, sunlight, zone, sunlight, zone, sunlight, sunlight zone. Then we go meh, because it's in the middle, because we remember meso was in the middle. Mesopelagic. And twilight has some sunlight, but not all the sunlight. So we're going to go zone, twilight, zone, twilight, zone, twilight, twilight zone. And then finally we have Bathpelagic zone, midnight, zone, midnight, zone, midnight, midnight zone. So that's kind of how that song works. Hopefully that helps you remember. Today we are doing, the first thing I want us to do is these ocean physical factors, and you can do this independently. So we're going to do the first. So you have two options, basically. You can pause this video, answer these questions on your own, or you can do them with me right now. So number one, as salinity increases, density does what? So remember, as we're adding salt to the water, it's becoming more pushed together. It's becoming more dense. So as salinity increases, density also increases. Number two, as temperature increases, density does what? So remember, towards the top of the ocean, we have our warmer layers, right? So as temperature increases, density decreases, because we're going towards the top of the ocean. If salinity decreases, density does what? Also decreases. If the amount of sunlight increases, the number of living organisms need sunlight to live, so that means increases. By the way, all of these are related to the ocean. If the amount of heat in the water increases, the density decreases, because we're going up in the ocean. If you go deeper in the ocean, temperature decreases. That's pretty easy. As we go deeper into the ocean, it gets colder and colder. If density decreases, temperature increases, right? Because if density is decreasing, we're getting closer to the surface, and so temperature is increasing. If you go deeper in the ocean, density increases. If you go shallower in the ocean, salinity decreases. If you go shallower in the ocean, life increases. So that's kind of just memorizing all of those things that we talked about yesterday. If you go deeper in the ocean, the saltiness of the water increases. If you go deeper in the ocean, life decreases. If pressure increases, depth increases. As pressure increases, the number of marine organisms decrease, because actually a lot of marine organisms can't handle that. So feel free to ask questions, but that's just kind of a review of what we did yesterday. That's kind of the graphs on the bottom, because it's showing as density increases, salinity increases. As depth increases, pressure increases. As depth decreases, ocean life increases. That was really hard. This is a new concept. Usually I would have greeted you at the door and gone through this like 600 million times before I asked you to do it by yourself. So I'm sorry that I have to do that, but just kind of use your notes and kind of use what we've been talking about as far as sunlight, less salinity, more salinity, less pressure, more pressure, less dense, more life, less life. So those couple of concepts of the ocean, then you can start comparing them together. So now we're going to move on to our lab experiment for the day. And it is here. This is our rainbow straw lab. So the question we're asking ourselves today is, when we put salt into water, will this make it more dense or less dense? So you need to make a hypothesis now. I predict that adding salt to water will make it more dense or less dense because, and you can use that whole activity we just did because we just talked about how salinity or the saltiness of the water affects things. Remember, salinity is a fancy word for saltiness. To pause this video for just a second, I want you to make sure that you're filling in the independent, dependent, and constants before we go over them. So at this point, I'm assuming you filled those in yourself, and we're going to go over the answers together. So the independent, oh, I'm sorry. You actually don't know what this experiment is. That's probably very frustrating. So if you figured this out, that's my dog. She really wants to get out. So I have here a bunch of different colors of water, and I have a dump bucket. Now, you do not have to do this experiment at home, but I'm going to walk you through it just so you, A, understand the scientific process, and B, so that you, if you wanted to do this at home, you absolutely could. So before we got here, I filled up 4 glasses. They can be the same height. They don't have to. Full of water. I put food coloring in them to make them different colors. You don't need 4 colors. It just looks kind of fun that way. And then these right now have no salt in them. I'm going to add salt. So you want to use a tablespoon, and salt, just regular salt, is fine. I'm not going to put any salt in this one, and I'm going to increase in salinity as we go this way. So in this first one, I'm going to put a half a tablespoon. In this next one, I'm going to put a full tablespoon. And in this last one, I'm going to put a tablespoon and a half. Go nuts on the last one. And then to create less dishes, I am going to reuse my tablespoon to mix it together. Mix, mix, mix. Mix, mix, mix. So this one is actually super saturated. There's so much salt in it that it won't all mix in. Okay. So obviously the red is the least salty, the blue is the most salty. And what we're going to do, you're supposed to use a straw. I don't have a straw, so I'm going to use a turkey baster. I'm going to remove the baster part, and I'm just going to use this cylinder. So you might have done this at a restaurant or something where you take your straw and you put it in, and you plug the top and you pull it out and there's some water inside. We're going to do that 2 different directions. So we're going to go from least salty to most salty and most salty to least salty. So when you're making your hypothesis and you're filling in these parts of the experiment, I want you to think about one of these ways the colors will mix and one of these ways they won't. So I want you to think about which way is it that's going to cause it to mix and which way is it that's going to cause it to not mix. Okay, so now that we've established that, hopefully you've written a hypothesis. Our independent variable, what we're changing is the order. A lot of times students, this is a really hard independent variable because a lot of times students think it's the amount of salt that we put into each cup. It's not, because the amount of salt in each individual cup is not changing with each time we're doing an experiment. The one thing we're changing is one time we're going to go this way and one time we're going to go this way. The dependent variable, how will we measure it? We're looking for whether or not the water mixes together or whether it stays stacked in a nice rainbow. Some things that we're keeping the same, we're not changing the amount of salt in each individual cup. The temperature is the same, which actually this is a very important one because temperature would make a huge difference here. The water is all about the same temperature. We're going to put the same amount of water for each color in. If you're doing this experiment at home, one thing I cannot stress enough is the importance of a dump bucket because once you get to the end of the line, you'll see you really need somewhere to dump this. Again, you're not required to do any of these experiments at home. It's just if you're bored and want to exercise some of your scientific prowess. So let's kind of move on. So we're going to go least to most salty. So this is my least salty. This is my most salty. So I'm going to go. I've never done this with a turkey baster before, so I'm like really scared. Oh, and that did not look super promising. Oh no, this is so sad. No, it's not working. Okay, I'm gonna pause and find a different vesicle. All about trying new things and coming up with solutions. I managed to look through my kitchen and I found one reusable straw. Straws are actually not great for the environment. That's why a lot of businesses are going to like paper straws or reusable straws because, like I said, they're not really great. We have a reusable straw here, so let's go for it. So we're going to go from least to most. So just like you would do at a restaurant or something, or at the dinner table, if you're me. Oh, and this one I didn't make deep enough. Okay, so you can see here, I actually have a whole stacked rainbow of colors. My red is on the top, my orange, my green, and my blue. So as you see, as I do this, it actually kept the rainbow. And if you watch really carefully, you can see a rainbow dropping. Ready? 1, 2, 3. So pretty awesome. So if we go back to our lab sheet, we're going to fill in that. Oh no, this is not working. I got some water on my thing. This is just a mess today. My dog is like barking in the background, can't find the right straw. Okay, so as we put in our observations, I want you to write what you observed, some of the things I observed, and again, we're collecting qualitative observations because this doesn't involve numbers, is that the rainbow was stacked, the colors did not mix. So now we're going to go least to most salinity, most to least salinity, so we're going to go backwards. Start blue. And you can already kind of see the colors mixing together. It like wants to get out into the other colors so bad. All right, so you see this kind of looks like a disgusting brown color. And totally the colors did not stack. No rainbow at the end. So now we're going to go random. So I'm going to start here. Then I'm going to go to green. So you can see those colors stacked, but then I'm going to go back to orange. Those two colors mixed, and then I'm going to go to blue. So you can see my most and least stayed stacked, but my two middle ones, my green and my orange, they mixed together. So why in the world is this? So it's because if you think about it as a heaviness kind of thing, I know the correct word would be less dense, but I think it's a little bit easier to think about this as heavy. Because this one has less salt, even though it looks like I'm taking in the same amount of liquid, there's a little bit less stuff inside of this liquid than there is inside of this liquid. If you kind of look at the water level, even though I added different amounts of salt, the overall water level didn't change all that much. What I'm increasing is the amount of particles in between each of those water particles. That's kind of what dissolving means. And so this one is going to be the less heavy. So when it's on that pyramid, visualize that person pyramid. When it's on the top, it likes to be there. It's not going to sink. Imagine putting the lightest person at the bottom of a pyramid. That's kind of what happens when we go from this way to this way. The heaviest water is on top and the lightest water is on the bottom, and so they mix. And in the random way, this happens because this one was where it wanted to be, this one was where it wanted to be, but these two are in opposite order. So they kind of got switched around. And there's our answer key. So make sure you fill out that conclusion. And hopefully you enjoyed this. I always love taking pictures of this one when we're actually in class because it is so beautiful to watch. Let's do it one more time, just because I put in a lot of effort to find a straw the cool way. So least heavy, it's where it wants to be. Then the next guy kind of falls in line. We're building our pyramid. This is the least dense. This is the most dense. Remember in science, whatever's deeper is more dense. This one's where it wants to be. And this one's where it wants to be. Watch the rainbow. And sneeze. That's where we're going to end today. Thank you so much for joining, and I will see you in a little bit for language arts.